So now we are in lesson 1.2. It's about arithmetic and geometric sequence. First, we're gonna do the arithmetic sequence. What does mean an arithmetic sequence? If the difference between two consecutive terms, consecutive it means one after the other one, is constant, we say that it's an arithmetic sequence, or we say also it's an arithmetic progression. And this constant, we call it the difference, and the notation is d. So the symbol of the difference is d. So let's do more formula, and then let's do an application. How do we prove, if you have a sequence, how you prove that it's an arithmetic sequence? You need to use the general form of the proving. You cannot just do the difference between two terms. You need to do un plus 1 minus un. So if it gives me a constant, it means it's an arithmetic sequence. How do we find the general term? It's un is equal to u1 plus n minus 1 times d. u1 is the first term. Surely you're going to tell me, Mister, if it's not the first term u1, let's say they want the first term is I name it u2, u3, u4. So I can write also like this. You can say up is equal, let's say q, for example, plus p minus q. So all the time the and d's down, we subtract times d. So it's the same. How do you find the sum of an arithmetic sequence? To find the sum of an arithmetic sequence, it's number of terms over 2 times the first term plus the last term. Normally, if the first term is u1 and the last term is un, so the formula will be n over 2, because between u1 and un, how many terms do we have? As I told you, how do we find the number of terms? You subtract the n's, n minus 1 plus 1, so it gives me n. So the number of terms is n. If I start with u0, it will be n minus 0 plus 1, so it's n plus 1. Let's say I'm starting by u2, it's n minus 2 plus 1, the number of terms. So those are the general formulas that we will see it more and more in the application. Let's do an application, as I said. Now, the fourth term of an arithmetic sequence is 18. When I see the fourth term, it means u4. So this is the first information. I have u4 is 18. And the common difference is minus 5. It means d is equal to minus 5. Determine the first term. It means I need to find u1. And the nth term, it means I need to find un. So I have two objectives in this question. I need to find u1 first, and I need to find un. So to be able to find u1, I need to use a general formula. Un is equal to u1 plus n minus 1 times d plus, which n is given as u4. So I will use u4 is equal to u1 plus 4 minus 1 times d. So u4 is 18, I will replace it. u1, I need to find it. 4 minus 1, 3 times d. What is d? Minus 5. And then you do the calculation. You solve for u1 and you will get u1 is equal to 18 plus 15, so it's 33. Excellent, I got u1. How are you going to find the general term? un, it means formula. un is equal to u1 plus n minus 1 times d. So already we have un is 33, and you know d is minus 5. I just need to replace, and I will get u, and this is a general term. And this one will help me to find any term that I want without having the preceding one. For example, I can find u100 by replacing n by 100 without getting u99 and u98. That's why it's very important to know how to find the general term of any sequence, so you can find any term that you want without getting all the preceding terms. Another example, they said here, find the number of terms. It means I need to find n in the sequence. It means I have the sequence. I need to know 83 represents u what? Is it u10, u100, u what? So I know that u1 is 20, and they mentioned here in this sequence, they should mention in this, let me write add arithmetic sequence, because if they didn't mention that, I cannot say directly it's an arithmetic sequence. Even if I can see it here, perhaps it's 20, 23, 26, then 24. I cannot do like this. So they should mention that. So I can find the difference by subtracting any two numbers, 23 minus 20 or 26 minus 23. So I know that d is 3. My objective is to find n. So I need to use a general formula, because what's given, this is un. I know that un is equal to u1 plus n minus 1 times d. What is un? Un is the number 83. So it means 83 is equal to 20, this is the first term, plus n minus 1 times 3, and then I just solve for n. So I continue developing here. I will have 20 plus 3 n minus 3. Then I solve, and I got n is 22. What does it mean? It means that 83 is u22. So this is the number of terms of this sequence. Let's move now to the geometric sequence. What does mean a geometric sequence? If the ratio of two consecutive, I said the ratio, it means the division of two consecutive terms in a sequence, sorry for my handwriting, is equal to a constant, then it is a geometric sequence. So here I'm doing over. In the arithmetic, we do minus. Here I'm doing over. And the common ratio is denoted by r. So how do we prove a geometric sequence? We do un plus 1 over un, and it should give me a constant. If it doesn't give me a constant, it's not a geometric sequence. What is the general form? Exactly the same like the preceding one. Un is equal u1 times r exponent n minus 1. And if I want to make it more general, I can write up is equal uq times r exponent p minus q. So sometimes I can start by u2, u3, u0. For the sum, again, it's the first terms times 1 minus r, number of terms, I'm sorry for the handwriting, over 1 minus r. So if I'm starting by u1 and I'm ending till un, what will be the number of terms? It's n. So Sn is equal u1 times 1 minus r, exponent n over 1 minus r. Let's move, guys, to a small remark. Now, if R is 1, what do we say about this sequence? We say it's a uniform sequence. Example, it means I'm multiplying by 1, 2 times 1 times 2 times 1, 2 to 2, so it's a uniform sequence. If R is 0, it's not at all interesting, the sequence, because I have just the first term as not equal to 0, and then all the remaining is 0. And if R is minus 1, we say it's an oscillating sequence, because one term gonna be positive, negative, negative, positive, positive, negative. So also it's not really interesting, this sequence. Let's move to convergent and divergent series. What does it mean? An infinite geometric sequence, and I'm writing here infinite, so it should be the last term, n is infinity. Okay, so it's r from 1 till infinity, is convergent when the sum tends to a finite value as the number of terms gets bigger. So when I'm adding more and more and more, in the end, the total sum is ending to tend to a number. And if it doesn't converge, it's said to be divergent. If it does, it's not the case, we said divergent. How do we know that the sequence is convergent? R, the ratio should be between minus 1 and 1. When R is between minus 1 and 1 and R is 0 point something, Rn, what's going to happen to Rn? Because we know that the sum of a geometric sequence, that is Rn here. Did you see it? So when n is tending to infinity, R going to tend to 0. When you have 0.1 times 0.1, it's going to be 0.00. Now, more 0 point times, you're going to have the answer 0.0000 something. So when n is tend to infinity, so this R is tending to 0. So it means here it's going to be 0. So what I still have here, I have u1 times 1, so it's u1 over 1 minus R. So it means when I have a convergent sequence, it means I need to see that n is tending to infinity. I want to see the ratio of between minus 1 and 1. So I can, when I'm doing the sum, the formula will be Sn is equal u1 over 1 minus r. You will see it in the application. Let's do some application. State whether each sequence is arithmetic, geometric, or neither. So if I look at the first example, 3, 6, 12, 18. So to check, I need to subtract first and see if it's the same, and to divide. If I do 6 minus 3, so it's 3. 12 minus 6 is 6, so it's not arithmetic. And if I do over, it's not geometric. This way is to prove it's not. But I cannot say if I got the first two subtraction 3, directly it's arithmetic. When I want to prove arithmetic, I need to use a general formula. You will see in another example. So in this case is neither. Same for 2. It's not arithmetic and not geometric. So if I over or subtract, it's not the same, so it's neither. Now here 3. If I want to see un is equal to n minus 3, is it arithmetic or geometric? So geometric, I need to do un plus 1 over un. And arithmetic, I need to do un plus 1 minus un. So let's start by finding first un plus 1. It means I'm replacing n here by n plus 1. So it's going to be 2 times instead of n plus 1 minus 3. Then I develop, it will be 2n plus 2 minus 3. So it's 2n minus 1. And now I will do over and minus. If you do un plus 1 over un, it means 2n minus 1 over 2n minus 3. It's not a constant. I cannot simplify, so it's not geometric. Now, if I do minus, I will have 2n minus 1 minus 2n plus 3, the answer is 2. It gives me a constant. It means that it is an arithmetic sequence. So this is the way how do we prove an arithmetic sequence. Let's move to another example also. I'll just do this one. The remaining one we'll do it together in the class. Here, if I have, for example, here this one, there is two methods. Either I can take this to other side and I can see that the difference gives me 2. And if you didn't see it like this, let's find the n plus 1. An plus 1 means I'm replacing n by n plus 1. So it's going to be n plus 1 minus 1 plus 2. So it's an plus 2. And then let's start to do an plus 1 minus an. So an plus 1, it's an plus 2 minus an. We cancel it and it's 2. So it means it's a arithmetic sequence. For the sequence, for the example 5, let me see, do I still have much more? Anyway, the application, we can do it in the class. So let's do 5, for example. Bn is equal to n plus 1. If I want to find Bn plus 1, it's going to be 2n plus 1 plus 2, so 2n plus 3. If I do Bn plus 1 over Bn, and I need to subtract the exponent, I will get in the end 2. So 2 represents the ratio, so it's a geometric sequence. I just want to move to a small application to see the convergent. I want to prove that 1 over 2 minus 1 over 4, all this, the sum is 1 over 3. If you look at this part here, this one represents the geometric sequence, because to pass from here to here, I'm doing times minus half. So the ratio is minus half, and the ratio is between minus 1 and 1. What does it mean? It means it is a convergent sequence. And it's an infinite. Did you see that? If it's not, there is no dots here, I cannot use the formula of the convergent. So it's going to be the sum at infinity. Formula, it's u1 over 1 minus r. What is the first term? Half over 1 minus minus half, 1 plus half. So it gives me half over 3 over 2. So it gives me 1 over 3. The last example is the same idea. So I need to show that this sum is 1 over 8. If I combine those together, 1 over 3 plus 1 over 27 plus 1 over 243, this one represents the geometric sequence. Also, it's a sum till infinity, and the ratio is 1 over 9 less than between minus 1 and 1, so it means it's convergent. So what is the sum of a convergent sequence? It's u1, this is u1 over 1 minus r. Excellent. The second part, it's minus. Also, it's a geometric sequence. The ratio is 1 over 9. So the sum is the first term, 2 over 9 over 1 minus r. And when you do the subtraction, in the end, you're going to get, as a calculation, 1 over 8. So in this example, I use the convergent sequence. When you see those, it means it's infinity. And then the preceding example also, I use the convergent sequence. That's it for this lesson. Sure, we will do more application in the class and watch it again more and more to understand this concept, and see you in the next video.